Hi there, mathematicians. Let's get started with areas of circles and sectors, section 11.2. Our objectives are to use the formula for area of a circle, use the formula for population density, find areas of sectors, and use areas of sectors. So our essential question is, how can you find the area of a sector of a circle? So let's start with our core concept for this lesson, area of a circle, noted by a capital A. It's the area of a circle is always capital A equals pi times the radius squared. So r squared, where r is the radius of the circle. So here we have an example of a circle. Remember, you have infinitely many radii. So anywhere you draw a segment from the center to any point on the circle, you're dealing with a radius. So let's take a moment to practice using our formula for area of a circle. So find each indicated measure. So part A, area of a circle with a radius of 2.5 centimeters. So let's start by writing out the formula. So capital A equals pi times r squared. Next, we want to substitute the values that we are given. So we're given the r value. So we substitute 2.5 in place of r. Remember that 2.5 needs to get squared, resulting in 6.25 times pi. And if I ask you to leave it in terms of pi, this would be your final answer. In other words, this is our exact area for the circle that has a radius of 2.5 centimeters. But you can type this in the calculator and get an approximate value. And it's approximately 19.63, so rounded to the nearest hundredths rather than the thousandths, centimeters squared. All right, let's try this next one. We have a diameter of a circle with an area of 113.1 centimeters. We want to find the diameter knowing the area. So first start with the formula, which is capital A equals pi times r squared. We can substitute 113.1 in place of capital A. Next, we want to divide both sides by pi. Remember, we're trying to figure out the diameter. We know that the diameter is 2 radii, like 2 lengths of radii, so we need to figure out what r is first, and then we can double it. So radius comes out to be approximately 6 centimeters. So we could double that, and the diameter will be about 12. All right, let's use the formula for population density. So population density is essentially of a city, county, or state, and it measures how many people live within a given area. So we do have a special formula. Population density equals the ratio of number of people to area of the land. And population density is usually given in terms of square miles, but can be expressed using other units. Oops, I misspelled units. So take out the E, such as city blocks. All right, let's take a look at 2 examples where we can use our formula for density. So there's about 430,000 people that live in a 5-mile radius of a city's town hall. Find the population density in people per square mile. Always start off by writing your formula. Then substitute values. So we know that there are 430,000 people, and then the area of the land is 5 radius. So we square the radius times pi. So pi r squared is the area of the circle of the land. So 25 pi is substituted for area of land. We type that in the calculator, we get approximately 5,475. So the population density is about 5,475 people per square mile. All right, let's take a look at our second example. A region with a 3-mile radius has a population density of about 6,195 people per square mile. Find the number of people who live in the region. Start by finding out the area of the region. So use your pi r squared formula for area of a circle. With a radius of 3, we substitute r with 3. resulting in 9 pi to be exact, and then we know that this is approximately 28.27. So next we want to write out our new population density formula, which is the ratio of number of people to area of land. Next we substitute number of people with 6,195 and area of land with 9 pi. Type that in our calculator and we get approximately 175,159 for the population. All right, our next core concept is finding area of sectors. So to start, a sector of a circle, it's the region bound by 2 radii of a circle. So let's take a look at our picture here. We have radii AP and we have radii BP. So what this is saying is it's the region, so it's the shaded region that we can see that's a different color, bounded by the 2 radii that we just named and identified, and their intercepted arc. And here's the intercepted arc, arc AB. So this entire region is called a sector. So to find area of a sector, it's the ratio of the area of a sector of a circle to the area of the whole circle, which we just practiced by using our pi r squared formula, and is equal to the ratio of the measure of the intercepted arc to 360 degrees. This second ratio we've dealt with already in section 11.1 when we were finding arc length. So this is pretty cool that we get to use this same ratio again in a new formula for finding area of a sector. So here it is set up with a shortened abbreviation of words and then also symbols. So our first ratio will be the area of the sector. In this case, our sector is A, P, B. This bounded region is our sector. So if we're trying to figure out the area of this sector, we would divide by the area of the entire circle, which would be pi r squared, so the whole. And it's equal to the measure of arc AB, so the measure of arc AB to 360 degrees. All right, just fix the formula there. So measure of arc AB divided by the entire measure of a circle, which is 360. So think of your ratios like this. It's your part out of the whole. So if I'm taking part of the area, then I'll do, that's called a sector, and then the whole area. Now if I'm just finding the area of this sector, I can multiply both sides by pi r squared. So another version of this same formula is to just get pi r squared on the other side, multiplied by your ratio. Looks like I need to fix this again. So you can do measure of angle arc AB divided by 360, all multiplied by pi r squared. All right, so let's take a look at an example where we can use our formula. So find the areas of the sectors formed by angle UTV. Using our prior knowledge in Unit 10, if the measure of angle UTV, which is a central angle here, is 70 degrees, then the measure of arc UV is also 70 degrees. And then we can figure out the rest of the circle, so the rest of your section over here, the blue section, its arc measure from U to S to V is 70 subtracted from the whole, which is 360, getting us a measure of arc USV to be 290 degrees. So to find the area of this small sector, we want the measure of arc UV divided by 360 times pi r squared. Substitute all the values that we just calculated and or figured out. So measure of arc UV is 70 degrees, so substitute here in the numerator, divided by 360, so part out of whole, times pi, and then r is 8 squared. So our small sector comes out to be about 39.10 square inches. We can do the same setup for finding the large sector. So the measure of arc USV out of 360 degrees times pi r squared. Substitute 290, we just calculated that up here. out of 360, so part out of whole, times pi r, still dealing with a radius of 8, resulting in about 161.97. So the areas of the small and large sectors are about 39.10 square inches and about 161.97 square inches, respectively. Our next example, we want to use the area of sectors. And we want to find the area of circle V. So we know the area of our sector bounded by the angle TVU to be 35 square meters. We want to figure out the area of the entire circle, so we don't know our radius. So we know the area of the sector TVU is equal to the measure of arc TU, so this arc here, out of the entire circle degrees 360, so part out of whole, times the area of the entire circle. So we can substitute 35, because we know that the sector area is 35, so all of this side, left side of the equal sign gets substituted with 35. We know that our central angle is 40 degrees, therefore the measure of arc TU is also 40 degrees, so 40 out of 360. We're trying to figure out the area of the circle, so this is unknown. So we can multiply both sides by the reciprocal of our fraction 40 divided by 360. And the reciprocal is 360 divided by 45. So multiply that fraction on both sides, resulting in 315. So the area of circle V is 315 square meters. All right, our final example, finding the area of a region. A rectangular wall has an entrance cut into it. You want to paint the wall. To the nearest square foot, what is the area of the region you need to paint? So let's just do a quick summary of what we're trying to figure out here. We're going to need to figure out the area of the entire wall. And we need to set it equal to, we know that the whole area of the wall is going to be equal to the area of the rectangle. So that's kind of this blue part, and if it was all filled in completely, this entire rectangle here, minus area of the semicircle, so it's subtracting this half circle right here, plus the area of the square, so this piece right here. So if we combine these two parts and we would subtract the total, we would then get the area of the wall that needs to be painted. So let's plug in all our values that we know. So area of a rectangle would be 36 by 10 plus 16, so a full 26. That's this part of the formula. Subtracting, and then area of the semicircle would be 180 is the half circle degrees out of 360 total, times pi r squared. Remember, this is to find the area of a sector. We're trying to find the area of this entire region right here, a half circle. And our radius we know is 8 because the diameter is 16, so half of 16 is 8, plus our area square of the square, which is 16 squared. So 16 times 16. So this little region right here is what we're figuring out there at the end. So doing our order of operations, we get 936 minus 32 pi plus 256. And that typed into the calculator comes out to be 579.47. So the area you need to paint is about 579 square feet. All right, that's all for today. I leave you with this 80s geometry class cartoon. When I think of sectors, I definitely think of Pac-Man and Mrs. Pac-Man. All right, see you in class.